Everything welcomes you to a military weapons channel. Everything smiles with joy at your arrival. Everything wishes for your participation, interaction, and wonderful creativity. The Eurofighter Typhoon is a twin-engine, canard delta-wing, multi-role fighter. The Typhoon was designed originally as an air superiority fighter and is manufactured by a consortium of Airbus, BAE Systems and Leonardo. First prototype of the finalized Eurofighter made its first flight on March 27, 1994. The aircraft's name, Typhoon, was adopted in September 1998, and the first production contracts were also signed that year. The sudden end of the Cold War reduced European demand for fighter aircraft and led to debate over the aircraft's cost and work share, and protracted the Typhoon's development. The Typhoon entered operational service in 2003 and is now in service with the Air Forces of Austria, Italy, Germany, the United Kingdom, Spain, Saudi Arabia and Oman. Kuwait and Qatar have also ordered the aircraft, bringing the procurement total to 623 aircraft as of 2019. The Eurofighter Typhoon is a highly agile aircraft, designed to be a supremely effective dogfighter in combat. Later production aircraft have been increasingly better equipped to undertake air-to-surface strike missions, and to be compatible with an increasing number of different armaments and equipment, including Storm Shadow and Brimstone missiles. The Typhoon had its combat debut during the 2011 military intervention in Libya, with the UK's Royal Air Force and the Italian Air Force performing aerial reconnaissance and ground strike missions. The type has also taken primary responsibility for air defense duties for the majority of customer nations. Role: multi-role fighter. National origin: multinational. Manufacturer: Eurofighter Jagdflugzeug GmbH. First flight: March 27, 1994. Introduction: August 4, 2003. Status: in service. Primary users: Royal Air Force, German Air Force, Italian Air Force, Spanish Air Force. Produced 1994. Present number built 571. Aerospace, EAP. Design: the Typhoon is a highly agile aircraft, both at supersonic and at low speeds, achieved through having an intentionally relaxed stability design. It has a quadruplex digital fly-by-wire control system, providing artificial stability, as manual operation alone could not compensate for the inherent instability. The fly-by-wire system is described as carefree and prevents the pilot from exceeding the permitted maneuver envelope. Roll control is primarily achieved by use of the ailerons. Pitch control is by operation of the canards and ailerons, because the canards disturb airflow to inner elevons, flaps. The yaw control is done by big single rudder. Engines are fed by a chin double intake ramp situated below a splitter plate. The Typhoon features lightweight construction, 82% composites consisting of 70% carbon fiber composite materials and 12% glass fiber reinforced composites, with an estimated lifespan of 6,000 flying hours. Radar signature reduction features. Although not designated a stealth fighter, measures were taken to reduce the Typhoon's radar cross-section, RCS, especially from the frontal aspect. An example of these measures is that the Typhoon has jet inlets that conceal the front of the engines, a strong radar target from radar. Many important potential radar targets, such as the wing, canard and fin leading edges, are highly swept, so they will reflect radar energy well away from the front. Some external weapons are mounted semi-recessed into the aircraft, partially shielding these missiles from incoming radar waves. In addition, radar-absorbent materials, RAM, developed primarily by EADS DASA, coat many of the most significant reflectors, such as the wing leading edges, the intake edges, and interior, the rudder surrounds, and strakes. The manufacturers carried out tests on the early Eurofighter prototypes to optimize the low observability characteristics of the aircraft from the early 1990s. Testing at BAE's Wharton facility on the DA4 prototype measured the RCS of the aircraft and investigated the effects of a variety of RAM, coatings and composites. Another measure to reduce the likelihood of discovery is the use of passive sensors, Pirate IRST, which minimizes the radiation of treacherous electronic emissions. While canards generally have poor stealth characteristics from side because of corner to hull, the flight control system is designed to maintain the elevation trim and canards at an angle at which they have the smallest RCS. Cockpit. The Typhoon features a glass cockpit without any conventional instruments. It incorporates 3 full-color multifunction head-down displays, MHDDs. The formats on which are manipulated by means of softcase, XY cursor, and voice, direct voice input or DVI, command, a wide-angle head-up display, HUD, with forward-looking infrared, FLIR. A voice and hands-on throttle and stick, voice plus HOTAS, a helmet-mounted symbology system, HMSS, a MIDS, a manual data entry facility, MDEF, located on the left glory shield, and a fully integrated aircraft warning system, with a dedicated warnings panel, DWP. Reversionary flying instruments, lit by LEDs, are located under a hinged right glory shield. Access to the cockpit is normally via either a telescopic integral ladder, or an external version. The integral ladder is stowed in the port side of the fuselage, below the cockpit. User needs were given a high priority in the cockpit's design. Both layout and functionality was developed with feedback and assessments from military pilots and a specialist testing facility. The aircraft is controlled by means of a center stick or control stick and left-hand throttles, designed on a hand-on throttle and stick, HOTAS, principle to lower pilot workload. Emergency escape is provided by a Martin Baker Mk-16A ejection seat, with the canopy being jettisoned by 2 rocket motors. The HMSS was delayed by years, but should have been operational by late 2011. Standard G-force protection is provided by the full-cover anti-G trousers, FCA-GTs. A specially developed G-suit, providing sustained protection up to 9G. German and Austrian Air Force pilots wear a hydrostatic G-suit, called Libel, Dragonfly, Multi-G Plus instead, which also provides protection to the arms, theoretically giving more complete G tolerance. In the event of pilot disorientation, the flight control system allows for rapid and automatic recovery by the simple press of a button. On selection of this cockpit control, the FCS takes full control of the engines and flying controls, and automatically stabilizes the aircraft in a wings level, gentle climbing attitude at 300 knots, until the pilot is ready to retake control. The aircraft also has an automatic low-speed recovery system, ALSR, which prevents it from departing from controlled flight at very low speeds and high angle of attack. The FCS system is able to detect a developing low-speed situation and to raise an audible and visual low-speed cockpit warning. This gives the pilot sufficient time to react and to recover the aircraft manually. If the pilot does not react, however, or if the warning is ignored, the ALSR takes control of the aircraft, selects maximum dry power for the engines, and returns the aircraft to a safe flight condition. Depending on the attitude, the FCS employs an ALSR, push, pull, or knife-over maneuver. The Typhoon Direct Voice Input, DVI, system uses a speech recognition module, SRM, developed by Smiths Aerospace and Computing Devices. It was the first production DVI system used in a military cockpit. DVI provides the pilot with an additional natural mode of command and control over approximately 26 non-critical cockpit functions to reduce pilot workload, improve aircraft safety, and expand mission capabilities. An important step in the development of the DVI occurred in 1987 when Texas Instruments completed the TMS-320C30, a digital signal processor, enabling reductions in the size and system complexity required. The project was given the go-ahead in July 1997, with development carried out on the Eurofighter Active Cockpit Simulator at Wharton. The DVI system is speaker-dependent, requiring each pilot to create a template. It is not used for safety-critical or weapon-critical tasks, such as weapon release or lowering of the undercarriage. Voice commands are confirmed by visual or oral feedback and serves to reduce pilot workload. All functions are also achievable by means of a conventional button press or soft key selections. Functions include display management, communications, and management of various systems. EADS Defense and Security in Spain has worked on a new non-template DVI module to allow for continuous speech recognition, speaker voice recognition, with common databases, for example British English, American English, etc., and other improvements. Specifications. General characteristics. Crew, 1 or 2, length, 15.96 meters, wingspan, 10.95 meters, height, 5.28 meters, wing area, 51.2 square meters, empty weight, 11,000 kilograms, gross weight, 16,000 kilograms, max takeoff weight, 23,500 kilograms. Fuel capacity, 4,996 kilograms, 6.215-liter internal, power plant, 2 Eurojet EJ200, after burning turbofan engines, 13,000 pound forces, thrust each, dry, 20,000 pound forces, with afterburner. Performance. Maximum speed, 2,125 kilometers per hour at 11,000 m altitude, 1,530 kilometers per hour at sea level. Range, 2,900 kilometers. Combat range, 1,389 kilometers. Air defense with 10-minute loiter ground attack. High-low-high, with 3 external 1,000-liter tanks. 185 kilometers air defense with 3-hour combat air patrol, with 3 external 1,000-liter tanks. 601 kilometers ground attack. Low-low-low, with 3 external 1,000-liter tanks. Ferry range, 3,790 kilometers, plus with 3 drop tanks. Service ceiling, 19,812 meters. G-limits, +9, -3. Rate of climb, 318 meters per second. Wing loading, 312 kilograms per square meter. Thrust weight, 1.15. Interceptor configuration, brakes off to takeoff acceleration, 8-second, brakes off to supersonic acceleration, 30-second, brakes off to Mach 1.6 at 11,000 meters, 150-second, armament. Armament. Guns, 127 mm, Mauser BK-27 revolver cannon with 150 rounds. Hard points, total of 13, 8 under wing, and 5 under fuselage pylon stations, holding in excess of 9,000 kilograms of payload. Typical multi-role configuration for a Tranche 2 P1E would be 4 MRAM, 2 ASRAAM IRIS-T, 4 EGBU 16 Paveway IV, 2 1,000-liter supersonic fuel tanks, and a targeting pod. Missiles. Air-to-air missiles. AIM-120 MRAM, AIM-120C-5/7 planned for P2E, AIM-132 ASRAAM, AIM-9 Sidewinder, IRIS-T, MBDA Meteor. Air-to-surface missiles. AGM-65 Maverick, AGM-88 Harm, Brimstone, Taurus KEPD-350, Storm Shadow Scalp EG, Spear 3, planned. Mardyar anti-ship missile, Joint Strike Missile, planned. Bombs. Paveway 2-3 Enhanced Paveway series of laser-guided bombs, LGBs, 500-pound Paveway 4, small diameter bomb, planned for P2E. Joint Direct Attack Munition, JDAM, in the future, Hospo, in the future, Spice 250. Others. Up to 3x drop tanks for ferry flight or extended range loitering time, conformal fuel tanks on tranche 3 or later. Avionics. Your radar captor radar, passive infrared airborne tracking equipment, Praetorian DAS, Damocles, targeting pod, Lightning 3 laser targeting pod, Sniper advanced targeting pod. Engines. The Eurofighter Typhoon is fitted with 2 Eurojet EJ200 engines, each capable of providing up to 13,500 pound forces of dry thrust and 20,230 pound forces with afterburners. Using the war setting, dry thrust increases by 15% to 69 kilonewtons per engine, and afterburners by 5% to 95 kilonewtons per engine, and for a few seconds, up to 102 kilonewtons thrust without damaging the engine. The EJ200 engine combines the leading technologies from each of the 4 European companies, using advanced digital control and health monitoring, wide-chord airfoils, and single crystal turbine blades, and a convergent-divergent exhaust nozzle to give high thrust-to-weight ratio, multi-mission capability, supercruise performance, low fuel consumption, low cost of ownership, modular construction and growth potential. The Typhoon is capable of supersonic cruise without using afterburners, referred to as supercruise. Air Forces Monthly gives a maximum supercruise speed of Mach 1.1 for the RAF FGR4 Multirole version. However, in a Singaporean evaluation, a Typhoon managed to supercruise at Mach 1.21 on a hot day, with a combat load. Eurofighter states that the Typhoon can supercruise at Mach 1.5. As with the F-22, the Eurofighter can launch weapons while under supercruise to extend their ranges via this running start. In 2007, the EJ200 engine had accumulated 50,000 engine flying hours in service with the 4-nation air forces, Germany, UK, Spain and Italy. The EJ200 engine has the potential to be fitted with a thrust vectoring control, TVC, nozzle, which the Eurofighter and Eurojet consortium have been actively developing and testing, primarily for export, but also for future upgrades of the fleet. TVC could reduce fuel burn on a typical Typhoon mission by up to 5%, as well as increase available thrust in supercruise by up to 7% and takeoff thrust by 2%. Clemens Linden, Eurojet Turbo GmbH CEO, speaking at the 2018 Farnborough International Air Show, said 15% more thrust would allow pilots to operate with a heavily loaded aircraft in the battlespace with the same performance levels as they have today. The technology insertion also provides more persistence, giving aircraft longer range or longer loitering time. To achieve more thrust, we would increase the airflow and pressure ratios of the high and low pressure compressors, and run higher temperatures in the turbines by using the latest generation single crystal turbine blade materials. And with higher aerodynamic efficiencies, we can achieve a lower fuel burn. A third area of improvement would be the engine exhaust nozzle, which would be upgraded with the installation of a 2-parametric version allowing independent and optimized adjustment of the throat and exit area at all flight conditions, providing fuel burn advantages. The technologies for the different components are at a technology readiness level of between 7 and 9. The nozzle has been at ITP in Spain on a test bed for 400 hours. Operators: Austria, Germany, Italy, Kuwait, Oman, Qatar, Saudi Arabia, Spain, United Kingdom, Royal Air Force, 160 ordered, all of which have been delivered by September 2019. Performance: the Typhoon's combat performance, compared to the F-22 Raptor and F-35 Lightning II fighters and the French Dassault Rafale, has been the subject of much discussion. In March 2005, United States Air Force Chief of Staff General John P. Jumper then the only person to have flown both the Eurofighter Typhoon and the Raptor, said. The Eurofighter is both agile and sophisticated, but is still difficult to compare to the FA-22 Raptor. They are different kinds of airplanes to start with. It's like asking us to compare a NASCAR car with a Formula One car. They are both exciting in different ways, but they are designed for different levels of performance. The Eurofighter is certainly, as far as smoothness of controls, and the ability to pull and sustain high G-forces, very impressive. That is what it was designed to do, especially the version I flew. With the avionics, the color moving map displays, etc., all absolutely top-notch. The maneuverability of the airplane, in close-in combat, was also very impressive. The FA-22 performs in much the same way as the Eurofighter, but it has additional capabilities that allow it to perform the U.S. Air Force's unique missions. In the 2005 Singapore evaluation, the Typhoon won all 3 combat tests, including one in which a single Typhoon defeated 3 RSAF F-16s, and reliably completed all planned flight tests. In July 2009, former Chief of Air Staff for the RAF, Air Chief Marshal Sir Glenn Torpey, said that the Eurofighter Typhoon is an excellent aircraft. It will be the backbone of the Royal Air Force, along with the JSF. In July 2007, Indian Air Force Su-30 MKI fighters participated in the Indra-Danish exercise with the RAF's Typhoon. This was the first time the 2 fighters had taken part in such an exercise. The IAF did not allow their pilots to use the MKI's radar during the exercise to protect the highly classified Russian An-11M bars. The IAF pilots were impressed by the Typhoon's agility. In 2015, Indian Air Force Su-30 MKIs again participated in a Indra-Danish exercise with RAF Typhoons. Armament. The Typhoon is a multi-role fighter with maturing air-to-ground capabilities. The initial absence of air-to-ground capability is believed to have been a factor in the type's rejection from Singapore's fighter competition in 2005. At the time, it was claimed that Singapore was concerned about the delivery timescale and the ability of the Eurofighter partner nations to fund the required capability packages. Tranche 1 aircraft could drop laser-guided bombs in conjunction with third-party designators. But the anticipated deployment of Typhoon to Afghanistan meant that the UK required self-contained bombing capabilities before the other partners. In 2006, the UK embarked on the £73 million change proposal 193, CP193, to give an austere air-to-surface capability using GBU-16 Paveway 2 and Rafael Ultra Electronics Lightning III laser designator for Tranche 1 Block 5 aircraft. Aircraft with this upgrade were designated Typhoon FGR-4 by the RAF. Similar capability was added to Tranche 2 aircraft on the main development pathway as part of the Phase 1 enhancements. P-1E, SRP-10, entered service in 2013 Q1, and added the use of Paveway 4, EGBU-16 and the cannon against surface targets. P-1EB, SRP-12, added full integration with GPS bombs such as GBU-10 Paveway 2, GBU-16 Paveway 2, Paveway 4 and a new real-time operating system that allows multiple targets to be attacked in a single run. This new system will form the basis for future weapons integration by individual countries under the Phase 2 enhancements. The Storm Shadow and KEPD-350 Taurus cruise missiles, together with the Meteor Beyond Visual Range air-to-air missile flight trials, have been successfully completed by January 2016. The Storm Shadow and Meteor firings are part of the Phase 2 enhancement P2E program, which introduced a range of new and improved long-range attack capabilities to Typhoon. In addition to Meteor and Storm Shadow, the first live firing of MBDA's Brimstone air-to-surface missile, part of the Phase 3 enhancements P3E program, was successfully completed in July 2017. German aircraft can carry 4 GBU-48 1,000-pounds bombs. An anti-ship capability has been studied but has not yet been contracted. Weapon options for this role could include Boeing Harpoon, MBDA Mart, Seed Brimstone, and RBS-15. The Typhoon also carries a specially developed variant of the Mauser BK-27 27mm cannon that was developed originally for the Panavia Tornado. This is a single-barrel, electrically fired, gas-operated revolver cannon with a new linkless feed system, is located in the starboard wing root, and is capable of firing up to 1,700 rounds per minute. There was a proposal on cost grounds in 1999 to limit UK gun armament fit to the first 53 Batch 1 aircraft and not used operationally. Thank you very much for watching the video. Like, subscribe and share. We are waiting for your comments to enrich the content. Thanks again, and good night.